Hi guys, this is another tutorial for Smartphysics problem, and this problem called the AC circuit 2. Okay. So in this problem we have a circuit that has a generator, an inductor, capacitor, and resistor. They give us all these information, C, L, R, the voltage across the generator max. And then they gave us that at time equals 0, this is the initial condition, that the voltage will be max and the VL will be 60.6 voltage and the voltage across the capacitor will be minus 10.1. Okay, and the question is asking about the time when the I will be max after time equal 0. Okay, so how can we find that? Is that the T will be phi divided by the omega. Okay, the phi will be in radian. Okay, let's look at the problem now, what we need to do. Okay. So here, since at time equals 0 the generator is max voltage, so it's going to be here, and it's positive. This will be okay, and they give us that the voltage across the inductor is 60.6, and the voltage across the inductor will be like the vector for it is after the voltage of the generator, so it should be, so since this is 120, so it's gonna be here, the 60, so it's almost here. Okay, and the VC is going back because it's negative. This is the VC, this is the VL, and the VR is always perpendicular to both, so it's going this way. Okay, so the phi we're looking for is this phi, and we want to find the omega, so we can just divide the distance, the angular displacement, divided by the angular displacement, so we can get the time. Alright. So I was trying to figure this out, but then the best way to do it is to get the ratio. So we're using a ratio. So let's see, VL at any time, or at time equals 0, will be VL max, and then since this one is positive, we want to use the sign omega t minus phi. Okay, so if we put the time equal to 0, sine of negative any angle will be negative, and this is positive. Okay, so we need to put this as a negative here. Okay, so the VC at time equals 0 will be VC max sine omega t minus v. This will leave it the same because sine of negative value will be negative, and we have the VC negative here. Okay. Alright, so if we take the ratio between VL divided by VC 0, this will cancel and we'll get minus VL max divided by VC max. Okay. Alright, so let's just substitute the values here, and this value here. So what is the VL max? VL max is I max times the, what is it, the XL, and the VC max will be I max divided by the XC. Okay, so we can cancel the I max, and the XL is L omega, and then the XC is 1 over omega C. Okay, and this will be equal to the initial, like to this here, which is VL initial over VC initial. Okay, and we have that here from the information here. So it's, and this is negative here, so it's the 60.6 divided by the minus 10.1. This value will go to 6. So, and putting all the algebra together, take this to the upper side, then minus, and take the minus sign from here and here. So it's omega squared LC, and this divided by this is equal to 6. Okay, so the omega will be equal to, let's keep it in variables, which is VL over VC0, and take the square root of it, and then it's LC. Okay, so this is the omega. We find one of the variables that we need to find the time. Now we need to find the phi. Okay, so the phi, if you look at it here, the phi is, if you say that this is VR and this is the voltage, so the phi is equal to the VR divided by the voltage across the generator. Okay, so what is VR? VR is the I max times the R. Okay, we have the R, but we don't have the I max, and we have the voltage across the voltage max. Okay, we need to find the I max now. So the I max is equal to, I is equal to V, which is the voltage across the generator divided by the Z, the impedance. Okay, so we need to find the Z now. Z is the square root of R squared plus XL minus XC. Alright, so we need to find now the XL, which is L omega, and the XC is 1 over C omega. Okay, so get the value of this, get the value of this, and then subtract the XL and the XC from this. XL minus XC, and then squared it, and then add it to the R squared, and you'll get the Z. Okay, so we get the value of Z. When we get the value of the Z, we can substitute it back in here, so we can get the I max. Okay, so I'll give you some numbers here. I got for the Z, let me look at here, I got 367.51 ohm, and then when I divide it by the voltage max divided by the Z, I got 0.3265 ampere, and my omega that I got was, I'm not trying to help you here, but just to give you an idea what the numbers are. So if you didn't get any like same number, you have to check your calculation. Okay, so here's the omega that I got, and here's the impedance, here's the current. So Alright, so now we substitute this back and the I max here. Then we'll get the phi in angles. Okay, this is actually cosine of this. Okay, so the phi will be now is cosine of the I max, which we got right here, times the r. The r we have from the question, and then divided by the voltage of the generator, V max. This is the inverse, cosine inverse. So the phi I got was it was 40.37 degree. Okay, so now we have the phi here, but it's in degrees, and to plug it back in here to use this one, we need to find the degree in radian. So I change this, so it's 180 pi. So to change this to radian, pi times 40.37 divided by 180. Okay. For this guy I got 0.7046 radian. Okay. So now just divide this by the omega and you'll get the time. And the time is for the VR here to get to the maximum value, because this is in phase with the current. The VR is in phase with the current. So the time to the VR to get to maximum is the same as the current getting to maximum. Okay, so this is the what is it called? The angular displacement. Yeah, the angular displacement. So divide the angular displacement by the velocity. Yeah, the angular velocity, which is the omega, which is 8.8. Where was it? 840.16 radian per second. Now the second will go up then. So the time is that I got was, I'm looking at my computer, it was 8.387 times 10 to the negative 4 seconds. Whew. Yeah, it was a tough problem, but I hope it helped, and good luck.